All right, welcome back, guys. We're going to keep trucking along. We're going to just talk about lesson 70 today, translations. We introduced this a week or so ago, and just kind of remembering what is a translation. That quick, short word that we kind of put in parentheses was a slide. We're going to slide something to one side or up or down or something. Definition should be the same. It was we're moving every point the same distance, and the same direction. Okay? Also, translations are isometry, or they're isometric transformations, meaning the shape will still be congruent. It will be the same shape and the same size, okay? But we could do this with just about anything, okay? What if I give you a point? Actually, let's go ahead and do a whole line. A, B, okay? And I asked you to move this line, A, B, 5 units up and 2 units to the right. Okay? Might need to even scoot that down. Oh, that will work. All right. So, ooh, I changed its color too. Look at that, how special that is. All right, so I'm going to take each point. So I might start with B. It would be helpful if I was on a pen. I'm going to start with B. And again, this is not real precise right now, but I would take each point and I'll go up 1, 2, 3, 4, 5 units up and 2 units to the right. So that would be B prime. Okay? I'm going to do the exact same thing with A. Okay? I'm going to go up 1, 2, 3, 4, 5 units up and 1, 2 units to the right. And that will be A prime. I connect that 2 points, then I have line A prime, B prime. Okay? Sounds pretty easy, sounds pretty simple. We're going to do a few different things with it. We're going to start with a graph. What if I wanted to move a shape? Okay, let's start with a rectangle. I'm going to put, oh, it's filled in. I didn't mean to fill it in. Let's try something a little different there. Let's paint this, we're going to fill it in. Let's put it a different color at least. All right, so we've got a rectangle, A, B, C, D, okay? And point A is at 1, 3. Point B is at 3, 5, 3. Point C is at 5, 1. And point D is at 1, 1. Okay, and we're going to take this rectangle A, B, C, D, and we're going to move it. Let's say we're going to translate A, B, C, D 3 units. I'm going to say right, and 2 units down. So we can go right, we can go left, we can go up, we can go down, okay? This is how we're going to talk about it in words. We'll talk about some different ways to do this, but we're going to start with words. So I'm going to take each point, I'm going to move it 3 units to the right and 2 units down, okay? If I'm going to the right, I generally start with points that are on the right. Maybe I'll change colors. That would probably be a little better. I'm going to start with B. Okay, I'm going to move B 1, 2, 3 units to the right and 2 units down. So that would become my B prime. Now I'm probably not going to do this little loopity thing on every single one, but you could. C, we're going to move 1, 2, 3 units to the right, 2 units down. And that would be C prime. Okay, A. We're going to do 1, 2, 3 units to the right, 1, 2 units down. So my A actually falls kind of on the shape still. Is that okay? Of course it's okay. D is the last one I'm going to move. We'll go 1, 2, 3 units to the right, 1, 2 units down. Somebody might ask, Miss Evans, after I do the first point, do I have to do that with all of them? No, you don't. Okay? If you see and find the first point, B, you realize that C is just 2 units below it, you can simply go ahead and put that point there. Okay? I do want to know what are the coordinates of A prime, B prime, C prime, and D prime. Okay? So B prime, we've gone 3 units over, so that's 5, 6, 7, 8, 1. C is going to be at 8, negative 1. D is going to be 1, 2, 3, 4, negative 1. And A prime is going to be at 4, 1. Okay, that's a little bit messy all jumbled in together, but you can see that they're related a little bit. Can you see that they're related a little bit? I hope you can. Maybe I'll erase this little bit right here. My eraser is really large. I'm going to remember 5, 3, okay? Yeah, I'm just going to erase that just real quick, put it back up there. 5, 3. What do you recognize? Can you make a relationship with a 5 and the 8? Was it 3 units added to the right? 5 plus 3 is 8. Of course it was. What about 2 units down? 3 to 1. Did we subtract 2? Yes, we did. Okay? That's going to lead us into another way of showing translations. Okay? It's called mapping notation. Okay? We'll have mapping notation with all of our transformations. Okay? I'm going to go ahead and go to the next page. I think I've got a few grids done. So we're going to talk about mapping notation. Mapping notation is going to be very specific. It's going to start with a T for a transformation. Okay? It's not necessarily translation because that's going to be the beginning of all of them. Okay? And we're going to map some x, y, that wasn't a frowny face. We're going to map some x, y to some other point, x plus whatever we're doing. If we were doing the last one, we would put a plus 3 there. Okay? And then we would put a y minus 2. That means our new xy's will be whatever our original x was, plus 3, and our original y, minus 2. Okay? Those are the numbers I used for the last shape. Maybe we'll do a different shape, and we'll do the same type of transformation. Let's do a triangle this time. Oh, let's go right there. I need to fill this in a little differently. Okay, so now, first thing we need to do is name our triangle. Let's name it X, Y, Z. Okay, we need a name. We need coordinates. 1, 2, 3, 4. Negative 4, 2. Negative 3. Negative 2. And Z is negative 5, negative 2. Okay? Sometimes it may just give you coordinates, okay, and say transform it this way, okay, translate it this way. But we're going to use our mapping notation that we have up here, okay, and say we're going to take our original xy, negative 4, 2. This one, it doesn't really matter which one you start with. I start on the right, however you want, okay? So I'm going to take x, and I'm going to map it x plus 3. I'm going to move it 3 units to the right and down 2, okay? We could take this negative 4, which is my x, plus 3, comma, y, which is 2, minus 2, okay, to see what our coordinates would be. So my x prime will be, that really is not equals, will simply be negative 1, 0. Is that where we landed? Yes, it is. So that will be my x prime. Okay? I'm going to take my y prime, y, and move it to y prime. Could I take this -3 and add 3 to it with my mapping notation? Yes. And then the y, which is -2, and subtract 2. Yes, we can. So my y prime would simply be 0, comma, -4. Because -2 plus a -2 gives me a -4. Could I count also? Of course you can. Go over 1, 2, 3, and down 2. That's where y prime will be. Is that the exact same point? 0, -4? It is. Okay? What about the z? Z I have -5. And I'm going to go back to this and say +3, -2, -2. So my z prime will simply be -2, comma, -4. Is that what I'm going to get if I count? If I go over 1, 2, 3, down 2. Is that my z prime? Yes, it is. And this is my translated triangle. Could we check to see, is it congruent? Could we have done that with the other one, the rectangle? Of course we could. Okay, here I'm just going to look at the area. So the base length is 2, and the height should be 1, 2, 3, 4. Base is 2, height is 4, my area is 4. Could I do the same thing here? Base is 2, height is 1, 2, 3, 4. Is my area 4 also? Yes, it is. Okay. My base, they're 2 units apart. Everything works out. I have, using the mapping notation, I have the coordinates for all 3 translated points. Okay. Good job. Here we go. Mapping notation, you don't have to be given a shape. Okay, I'll give you another one in just a minute. We're going to do one more with a graph, and we're going to use vectors. Do you remember vectors? I hope you do. The vector has both magnitude and direction. Okay, so if I give you a vector u has components of 1, I'm going to keep it fairly nice. We're going to do 1, 3. Okay? And we're going to start with a shape. Okay, let's start with a nice square shape. We're not going to, well, it doesn't matter. Fill it in. Don't fill it in. Okay. There's a fairly decent, look at a different color. There we go. We have a square that is QRST. And I want to translate it, the vector 1, 3. I actually don't want to do 1, 3 because that's not going to be near far enough. I'm going to translate it a little bit farther. Let's do it. I don't want 3, 3. Let's do 5, 3. 5, 3 would be a good number. Okay? So, every coordinate, I'm going to go 5 units to the right, 3 units up. Or actually, I'm going to draw a vector that's 5 units to the right, 3 units up. So, from every coordinate, every vertice, Q, R, S, T, I'm going to go over 1, 2, 3, 4, 5, and up 1, 2, 3. And I'm going to draw a vector from that point. Okay? I'm going to draw a vector from Q. 1, 2, 3. I don't want all those little dots there. So I'm going to start from Q. I'm going to go over 1, 2, 3, 4, 5, and up 1, 2, 3. We should end with a vector right there. Okay? S, I'm going to do the same thing. I'm going to go over 1, 2, 3, 4, 5, up 1, 2, 3. My vector from S is going to go right there. Now from T, that's going to be kind of in the middle, going over 1, 2, 3, 4, 5, and up 1, 2, 3. My last vector. Okay? So really, the end of all these vectors, there are points. If I connect those points, I'm going to do it in a different color, just so that you can see what color do we want. I'm going to go back to red. I'm going to go over 3, down 3, back 3, up 3. Is it still a 3 by 3 square? So my R up here would be R prime, Q prime, T prime, and S prime. Okay? We really have just made a 3D shape if we leave the vectors there. If the vectors are there, we now have a rectangular prism. Okay? Using the vectors, you can see we just have another shape over here. Now my side links are here in purple. Those are my vectors. Okay? It's that depth of my original 3 by 3 square. Okay? We can use vectors also in translations. Okay? So you have 3 different ways to do translations. Okay? I can just give you by words. Up 2 units, down, up 2 units, right 4 units. Okay? You can just tell them. Okay? You can use mapping notation. Okay? You can use words. You can use mapping notation. Or you could do it using vectors. Okay? So, here we go. Let's try 1 or 2. Oh, they do another one. Oh, how they do character stuff. That's always fun. Okay, so words we would say. Let's kind of give you an example of each one of these. Words we would say. We could say left 2 units, up 4 units. Okay? They're going to tell you in words, and you're going to take each point, each coordinate, and do that exact same thing. Left 2 units, up 4 units. Okay? Mapping notation will always start with a T, colon, X, Y. Then there will be an arrow. Okay? Then you would have an X. If we were doing this exact same one, we would have X minus 2. That right and left are your X's, up and down are your Y's. Okay? This says left 2 units, up 4 units. Okay? Mapping notation. If we were going to do this exact same thing with a vector, we would have the component, the little alligator mouth, and we would say -2, 4. That would be our vector notation, all saying the exact same things. We're moving left 2 units and up 4 units. All of these say the same thing. Okay? Now, there's an application. They talk about computer animation. A character in a new animated movie will move from point 4, -5 first to the point 16, 3. So we're going to start at 4, -5. And we're going to move to the point 16, 3. And then to the point 13, -2. Find the vectors the animators need to apply to the character to make these 2 translations. So here's our starting point. Okay? And we're moving to here, first move. And they're wanting to know, how can we get from 4, -5 to 16, 3? So to get from 4 to 16, what did we do? Yeah, we added 12. They want this in vector notation. Those little alligator mouths matter. It's not a parentheses. Okay? Now we get from -5 to 3. We have to really subtract 3 minus -5. And we've gone 8 units up. So our first move, they would have to have 12, 8. They would move on that vector. Okay? Now the second move, we're going to go from 16, 3 to 13, -2. What vector are we going to use to get from 16 to 13? Yeah, we've gone down 3 units. So that would be a -3. From 3 to -2, we've also gone down. So -2 minus 3, we've gone down 5 units. Okay, all I did was subtract 16 minus 4, comma 3 minus -5. Okay, I did 13 minus 16, -2 minus 3. Okay, so all you had to do was subtract. Okay, just a little bit of homework for tonight. Lesson 71. We're going to do the practice. And we're just going to do numbers 1 through 4. No, we're not going to do 1 through 4. Sorry. We're going to do 5 through 10. Perfect timing because my battery is about to be done. All right. I will see you guys another day. Text me or let me know if you have any questions. All right.